In this module, we'll connect the reference architecture to a concrete journey. You'll follow a user from starting account opening, through wallet presentation and verification, to a KYC decision and a created profile. As we go, pay attention to how each component collaborates end to end. Up to this point, we've been building the scaffolding for an eIDAS 2.0 onboarding solution. We started with the ecosystem actors and wallet journeys, then defined the business scenario and requirements that drive the design. From there, we layered on regulatory expectations and turned them into concrete controls, and most recently, assembled those pieces into a target component architecture. In this module, we'll bring that architecture to life as a concrete, end-to-end onboarding flow. This happy path journey is the clean, successful case we want to optimize for. A customer asks to open an account, and the relying party immediately triggers a wallet interaction, requesting exactly the attributes it needs. With the user's consent, the wallet releases those attributes. A verifier checks the presentation and returns trusted claims. Finally, the KYC engine applies risk and policy rules, and if everything passes, a customer profile is created automatically. The journey effectively begins the moment a customer taps Open Account in a web or mobile channel. That click triggers the backend to create a single onboarding session with a unique identifier. Everything else hangs off that ID: which product they're opening, what jurisdiction applies, what channel they're using, and why they're onboarding. At this point, we avoid storing verified identity data. We simply establish a traceable, auditable context to work within. Before triggering a wallet request, you first decide exactly what you need to know and why. Start from the business outcome and AML or KYC rules, what must be proven, and to what level of assurance. Then map each need to the minimal attribute and the minimal evidence that satisfies it. Different products, countries, and risk tiers will drive different mappings. Here, GDPR minimization is your brake pedal. If you can't justify it, don't request it. Once the verifier knows which attributes are needed, they package that into a wallet interaction request. This request clearly states which claims are required, why they're needed, who is asking, and where the response must be sent. It's cryptographically bound to the user's onboarding session, so it can't be replayed or mixed up. At the same time, it stays human-readable, while the underlying structure supports strong verification and later auditability. The key design question here is how the credential request actually reaches the user's wallet. On desktop, the usual pattern is a QR code. The browser shows the request, the user scans it with their wallet app, and the session on the website continues seamlessly. On mobile, you typically rely on deep links or app redirects. These must clearly show who's asking, avoid unexpected jumps, and keep the verifier's session intact to prevent phishing-like confusion. At this point, the wallet shifts from being a passive mailbox to an active privacy tool. The user sees who's asking, what data is requested, and why it's needed. Good design nudges the user to pause and check whether each attribute makes sense for this purpose. Consent must be explicit and reversible, not buried in small print. Approve, decline, or inspect further. The key is meaningful, informed choice every single time. Once the user approves, the wallet's job is to build a tailored, privacy-preserving response. It first selects the credentials that can satisfy the request, then filters them to only the attributes that are truly needed. That filtered set becomes a verifiable presentation, cryptographically bound to a specific relying party and session. The wallet then sends this presentation over the agreed secure channel, limiting exposure and preventing unnecessary data sharing. When the wallet sends a presentation, the verifier becomes the gatekeeper. It first matches the response to the correct onboarding session, so there's no mix-up between users or devices. Next, it checks that what came back actually satisfies the original request and passes all cryptographic and policy validations. Only then are the trusted claims forwarded to the onboarding backend, where KYC and risk engines decide whether to approve or decline the customer. Before any claim can be used for KYC, it has to pass a series of verification gates. You start by confirming authenticity and integrity. Was this presentation really created by the holder, and has it stayed unaltered? Then you check that the issuer is trusted for this type of attribute and that the claims actually answer your request. Finally, you verify status, expiry, and policy rules before you rely on the data. Even after a credential is verified, we don't just copy values over. We pick only the claims that passed validation, then clean them up. Names, dates, addresses, even country codes are normalized into the consistent formats your systems expect. Those standardized attributes are mapped into specific customer and KYC fields, while in parallel we attach rich metadata: who issued it, when it was verified, the assurance level, and what evidence supported it. Once identity is verified, the focus shifts from who is this person to should we do business with them. The KYC engine combines verified attributes with product, channel, and jurisdiction rules. It checks eligibility, screens sanctions and PEP lists, scores risk, detects duplicates, and applies fraud rules. Based on those results, it either auto-approves, rejects, asks for more evidence, or sends the case to a human reviewer for a final call. After KYC is approved, the relying party's job is to turn that decision into a clean, compliant customer record. Verified attributes are normalized and stored in the profile, while the decision outcome, timestamp, rule set, and evidence references go into dedicated logs. Consent is captured with clear purposes and retention periods. Critically, only what's needed is kept, enough for audits and regulators, but not full raw credentials or unnecessary wallet data. You've now seen the HappyPath Wallet onboarding journey end to end. Keep 4 ideas in mind. Maintain session continuity, request only necessary attributes, separate verification from KYC policy, and always link profiles to evidence, consent, and auditable records. In the next modules, we'll deepen trust validation, credential lifecycle, and exception handling.